Okay, so welcome to the new series of lecture, that is Zener Diode. Now we shall have this discussion in two different lectures. So first lecture is about the overview, and second lecture will be taking one application of Zener Diode as voltage regulator. So here uh, Zener Diode basically works in the reverse bias condition. Now to understand that, let us first have a look at the reverse bias characteristics of diode. So in reverse bias we know that if voltage across the diode increases, then initially we shall have very little conduction or no conduction, and there will be small current due to minority charge carriers, that is I naught it is denoted, which is called as the reverse saturation current, and generally it is in the range of microampere. That is for normal diode, it is correct. Now if we keep on increasing the reverse voltage, then at a particular voltage there will be a breakdown, and breakdown may be due to two reasons. One is the Zener breakdown and another is the avalanche breakdown. Now this breakdown we are not going to discuss here in detail, we may discuss that in some other lecture. We are interested on this Zener breakdown, which is mainly due to the reason of heavy doping. So if the doping condition concentration is quite high, then we can make sure that the breakdown occurs at a very lower voltage, lower reverse voltage. Now if a diode is heavily doped, then as I have mentioned, breakdown occurs at a lower value of reverse voltage, and breakdown voltage is more if the diode is lightly doped. Now if a diode is intentionally doped in such a way that it will operate in the breakdown region only, so then such kind of diode which can operate continuously in the breakdown region without any damage or without any other kind of problem, then we call such kind of diode as Zener diode. So it is quite natural that Zener diode, we are a normal diode, we are intentionally doping higher so that that particular diode can work as a Zener diode. Now if we have a look at this symbol, then this is the normal diode that we have discussed in our previous lecture series, and this is the Zener diode. This is the symbol of a Zener diode. Now the forward bias characteristics, if we have a look here, the forward bias characteristics is same as that of the normal diode, but the reverse bias characteristic is different from the normal diode. Here at a particular voltage that you can see here, it is denoted as the knee voltage. So here the breakdown occurs, and we are calling this as the Zener diode, and it is denoted as Vz. It is denoted as Vz, that by indicating that it's the Zener voltage. Now here in this breakdown region, Zener diode, a large reverse current results, and it will consequent on the application of reverse breakdown voltage, and it is termed as the Zener current, and it is denoted as IZ. Zener current is denoted as IZ. So here in this diagram you can see that how Zener diode is symbol of the Zener diode is given, and in practical how it look like. Now if we go to the equivalent circuit of a Zener diode, so this is a simple circuit of Zener diode. Now here As we have already seen, a Zener diode is always reverse biased during the normal working, and Vz denotes the Zener voltage and Iz denotes the Zener current. Now the voltage remains constant. The voltage across this diode, that remains constant even when the reverse voltage Vr is greater than the Vz, and the current through the diode is changing. That means voltage remains constant but current is changing. So hence this Zener diode may be shown as a battery of the voltage Vz with this kind of polarity as shown here. So this Zener diode can be replaced by a battery of Vz in the equivalent circuit if Vr is greater than Vz, whereas diode will be in off condition, that means normal reverse bias condition, when Vr is less than Vz. That means it is normal reverse bias condition. So if we have it is in the off condition or normal reverse bias condition, then Iz may be considered as 0, because diode is considered as if it is not conducting at all. So this is the equivalent circuit of the Zener diode. And now if we summarize our discussion, then following points can be noted. So first of all, a heavily doped semiconductor diode which is designed to operate in the reverse direction is known as Zener diode. So intentionally we are making this diode to operate in the reverse direction. Then in other words, we can say that it is specially designed for optimizing the breakdown region. Then the depletion region of Zener diode is generally very thin because of higher concentration of impurities, and heavily doping material increases the intensity of electric field across the depletion region of Zener diode, even for the small reverse voltage. So we can have different voltage, Zener voltage like 5 volt, 6 volt, 8 volt. So depending on the application, we can have different type of Zener diode. And the voltage across the Zener diode, so that is represented by this equation. So Vz plus IzRz. So drop across the diode and the voltage Vz. And Zener diode is used as voltage regulator, voltage stabilizer, in over voltage protection, in clipping circuits. So these are some applications of Zener diode, and the popular one is the voltage regulator. So join me for the next lecture where we will be discussing Zener diode as voltage regulator.